Hi, for this demo, we will be walking through a point-and-click demo of how automated machine learning, or AutoML, can be used to automate the process of generating machine learning models. Now, by no means is AutoML designed to replace a data scientist, but AutoML can be used to confirm a hunch, ensure you have enough predictive variables, and even help to decide on which is the best model to use. What you're looking at right now is a SEMOSS database. Within this database are three things: data, analytics, and insights and/or widgets. With regard to the data, we currently have a data set of 441 movies, including their genre, director, studio, and whether they were nominated for an Academy Award. We've split this data into a training and testing data set, with 80% of the data going into training and 20% going into the testing data. Also, within this database, we have custom analytics scripts saved. So, if I open up the asset browser and search for the files stored within this database, which in this case is called movies modeling, you'll see we have one .r file called automl.r. We can open this file and see its contents. This is then the file that will be used throughout the demo to generate our AutoML models and then ultimately predict from those models. So, returning back to our app homepage, we will be using two specific pre-made insights: AutoML model generation and AutoML model use. Now, let's open the first insight and see this particular insight. On the left, you see the data that we have. As I mentioned, this has to do with a lot of the movie titles, their genre, their IMDb score, financial data such as movie budget, and our target column, as you can see in the middle, nominated, with a Y for yes and an N for no. On the right is then when you'll see the AutoML model generator. So starting at the top, we'll select the dependent variable that will be used as our target column. We'll then select the attributes to include that can then drive the decision making for that target column. We can then select the runtime, or how long we want to be generating models for. In this case, we'll be choosing 10 seconds. And then we can also select the desired file name. So this is the file name that will then be stored within our database that we can then use later on in the demo. We'll select execute and we'll run this AutoML generation for, as we entered, about 10 seconds, where we'll be generating models, looking at some basic information regarding the output of those models, and ultimately determining which model is the best. So when the algorithm completes, as you'll see on the right, we've now added a new table to our view where we can see the models that were generated and some basic statistics around them. In this case, we generated around 7 models in our short time period. We also provide some basic information regarding these models and how we determine which model would be the best. We have the area under the curve, we have the mean per class error, and we have the mean squared error. These are just some basic information regarding each model to determine its validity. This is then the model that will be used in the next step of our demo, actually predicting whether or not a title is nominated or not based on our testing data. We'll return to our app homepage and open the second insight, AutoML model use. On the left, again, we see our same data set that we had before, except we only have 20% of our data versus 80% of our data. On the right, we can then select the file that represents our model that was previously created. So as you can see, we have the R file that we showed initially, but we want to select best model. And when we select execute, we then apply that stacked ensemble model that we created in the previous insight and applied this testing data to it. And now, as you can see, we've added a new column to our database called predicted. So in this case, we'll add title to our table. We'll add predicted to our table, and we'll add nominated to our table. And then we can see the difference, the same, the accuracy of each of these different measures. And ultimately, what we did was we used AutoML to compare many different types of machine learning models, and we could then explore the best models to dive deeper into, change any of our assumptions, or as we did in this demo, use those models generated on a new set of data. So thank you for watching, and I hope this provided some insight on automated machine learning and how it can be used on your own data sets. Thank you.